Hello guys. So let's have another class, basically a little lecture, an introduction to the TensorFlow under the bonnet sort of series of practices. Yeah. This time we're going to just make a very simple CNN sort of model, but we're going to be building it, using that TensorFlow under the bonnet approach with class before. So CNN, or shall we call it basic CNN with class. Yeah, I like that name. Okay, so let's go and import the necessary library. So I'm going to go import TensorFlow as TF. I'm going to from TensorFlow.keras dot so TensorFlow.keras import layers, yeah, and let's import numpy as well. Import numpy as np. Okay. So we have our libraries in, and let's go and make some dummy, well, not dummy, but example data. Yeah. Obviously, this is the idea is for you to understand the code and the structure. Yeah. And I will be addressing this data management in a bit more detail, very sort of little detail further. So let's just make the data. So xtrain equals np.random random let's say 120 by 20 and black and white, like images as if, yeah. And then shall we do it as type dot, yeah, let's make it dot as type np dot float, yeah, float 32. Okay, so just let me do this as well. Import matplotlib dot pyplot as plt. So if we look at our xtrain just for a second, so let's say xtrain, that's one of our xtrain, sorry, dot shape. Okay. Let's see if we can see plt.imshow xtrain 0. Oh, what did it do? Put a capital X here, didn't it? So we have basically, like created loads of these images, yeah. So I mean, like it's a matrix basically, it's not really an image, but that's not the idea. So I just wanted you to know that we're creating these 20 by 20 example images, 100 of them, so that we can, have this CNN working or playing with something. Okay. So while we make our xtrain, how about the label as well? Let me make it. We're going to call the labels as ytrain. Okay. Ytrain, I mean, it's going to be about, like, for example, cat or dog. I don't know, like binary. Yeah. So we're gonna say np.random.rand int this time. Yeah. Rand int. And let's say 0 to 2, and how many we want? Obviously needs to be 100 of them, yeah. And size equals 1, yeah. No, sorry, 10, 100. Oh, rand int, sorry. Okay, shall we look at y as well? Yeah, so y train. So as you can see, it's like 1, 2, 1, 2, 1, 2, you know. It's just, we can assume it's like the labels, yeah. So we can assume that this is like an images of cats and dogs, hundreds of them, and like 0 is a cat and 1 is a dog or whatever. Okay, so that's our data, all right? Let's talk about something. There is a method by which we can have a more efficient feeding of our data into TensorFlow models, yeah, into neural network models, and that's using TensorFlow.data.dataset, yeah, to create a TensorFlow pipeline data. You know, it's like an efficient way of feeding data into your model. So let's make a TF pipeline, 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 efficient, efficient data. Okay, and how are we going to do that? We're going to say data set. Okay, data set. We're going to be making this from our existing data. Okay, so if you had your own data, you just follow the same thing. So data set equals TensorFlow data set. I think, yeah, data set dot we call it from tensor slices function, from tensor slices, yeah. And guess what we're going to feed into this? Obviously we're going to be training, giving our x train and y train into this. Okay, and we're gonna also be creating a batch out of this. So then we're gonna just say data set equals data set dot batch. Let's go with batches of 32. Well, looks like it's just 100 numbers, but yeah, 32 is fine. Okay, data set equals batch 32. That's it. And I got an error. What the true value of an array with more than one element is ambiguous. Use any. What did I do wrong? Give me a second. Also, blah blah blah. Okay. Should be. All right. So that's our data set. Yeah. So we have two sources of data, guys. One is the training data that we just created, you know, X train, Y train, and the other is this data set. Yeah. So we're going to be practicing with both just to see which one is more efficient. But let's just go with the original data first and, you know, working with TensorFlow under the bonnet. Okay, now let's go and make our CNN model. So I'm going to say making a model. Making a model. Okay, so class CNN model. Yeah, that's a cool name. And we're going to inherit TensorFlow.keras.model. Okay. Next, we're going to say define in it. Yeah. Define in it self as inherited super parentheses dot init super, yeah, init, yeah, and then okay. So what does a CNN model have? Well, it has convolutional layers, isn't it? So let's start building them. Self dot conv1 equals, now we're going to inherit from layers, isn't it? Sorry, we're inheriting from models. Okay, so we're going to now use layers. So layers dot conv2d, conv2d, let's say 32 filters of 3 by 3 size. Yeah. And then activation is going to be relu. Okay, so activation is relu, and input shape is going to be 20 by 20, isn't it? Yeah, 20 by 20, and it's black and white, right? So that's that, and then that's our convolution. That's our first conv layer. Let's just flatten it after this here. Let's keep it simple. Self dot flatten, or flat, yeah, flatten flat, because layers dot flatten, and that just is flatten. Okay. All right. So this is our. I mean, we could have added max pooling, but just let's keep it simple. So we have a convolutional layer. Right away, we're going to flatten it, make a single vector. What we're going to add next? Well, we need a dense layer. So self dot dense 1, yeah, or first dense layer equals layers dot dense, and we're going to put, just like before, 64 neurons. Activation equals ready. Okay, and then self dot dense 2, yeah, or we can call it output maybe, 2 equals, I hope you guys are going to help me because I'm going to make a mistake, layers dot dense, and we're going to put just one input. Do you think that's good? I want you to think about it for a second. Is this all okay? Yeah? Do you think there is something wrong here? Well, I hope you have said yes. And well, there is nothing really wrong in terms of the code, but regarding our purpose, remember, we're trying to make a classification, CNN classification model, yeah? And if it's a classification, we need an activation function here, and that is, what is it going to be? Well, it's 0 and 1, so it's binary. So we're going to be using signal. I want you to think about what you would have done if you had multi-class classification, yeah? All right, so that's our class, and then let's define the call within it, okay? Although I've made a mistake here. Yeah, oopsie, why did I do that? Oh my God, that's funny. No, I need to do all of this. Indentation, very, very, very important, as you know. Okay. Yeah, okay. So define call, yeah. Define call, and then self, and then we're going to have our input. Let's call it X. And okay, what is our call? What task our call is going to be doing? So it needs to go through all of this, isn't it? Like these items that we made here. So we're going to make the call, and we're going to start with, so it takes a X in, and then we're going to change the X is going to become self dot conv 1, and after giving X, so we are updating X, then X equals self dot flatten, is it? Yeah, next one. Flatten what are we giving it? Well, x. Yeah, so this x is like moving around, getting fed to one another. And then x equals self dot dense 1, okay, and obviously x, and x equals self dot dense 2x, and what do you want to return? Well, the output x, isn't it? Return x, okay. Okay, so that's our call, our class, yeah. Let's just run it and make sure there's nothing wrong. Yeah, cool. All right, so that's done. We have made our model, okay. Now let's go and try to examine it, okay. But before that, let's make an instance of our model. So model CNN, yeah, equals CNN model, we call it, isn't it? Yeah, CNN model. And then let's define the, yeah, let's make an instance of a model, but let's make our optimizer now, okay? So optimizer CNN equals TensorFlow dot keras dot optimizers dot addon. Okay, so yeah, and the learning rate is pretty. So let's just leave it to the learning rate. It is, I don't want to like dive into that. Okay, so that's done as well. So we have our model instance of a model. We have defined an optimizer. Now we're going to do that fitting. Yeah, but we're going to do it for loops. Yeah. So for epoch in range 10. Okay. But there is one thing I want to show you. So let's do this. Yeah. What to do? And that is, let's do that. Okay. You will see what that does later. So for epoch in range 10, okay, so for I in range 10, whatever you want to put in there, whatever name it epoch, and with TensorFlow dot gradient tape as well, gradient tape as tape, okay. We're going to now utilize that model, okay. So preds equals, yeah, model CNN when it's fed with or x-train, okay, with an x-train. And what's the loss? So the loss is, yeah, be careful here. Loss is TensorFlow dot reduce mean. Reduce mean of what? Okay. What do we use, guys, for TensorFlow when when we were doing the fit function? Yeah, sorry, when we were doing the compile function, when we use the sequential sort of API. Well, for a classification of this sort, binary classification, isn't it? So it's binary cross entropy. Okay. So just be careful here. What we are going to be doing, loss is TensorFlow that reduce mean. Okay. And what are we going to feed into is TensorFlow dot keras dot losses dot binary cross entropy. Okay. And what is being fed to this binary cross entropy? It's going to be our y test and preds. Okay. So that's our loss function. Okay. So we've defined, how the model works. You're getting an x train fed into it, and then you're generating a loss. and you're calculating it like this, okay? And obviously we are doing this on a loop, okay? And on each loop we're going to be calculating the gradients and then adjusting the weight. So gradients equals tape dot gradient, and what are we going to feed into it? We're going to feed our loss, and we're going to feed our trainable variables. So what's our model name? Model CNN. Model CNN dot trainable variable. Okay. So that's our gradients. Okay. Now our optimizer. Okay. We're gonna we need our optimizer working. So we're gonna call our optimizer what did we call it? Optimizer. Optimizer CNN. And we're gonna call apply gradient. Yeah. So we calculate the gradient and then we apply this gradient. Dot apply gradient, and we're gonna give what to it. We need to zip the gradients, and obviously the trainable variables. Yeah, model CNN dot trainable variables. All right. So I think this is right. So we're gonna run for 10 epochs, and I want you to appreciate what this is going to do next. Yeah, so let's just go and do that, and then we get an error. Okay, because we don't have a white test, do we? We have white train. Okay, yeah, that should be okay now. So it's just 10 epochs. Look at this, guys. CPU time user 1.06 second, system 66.2 milliseconds, total is 1.13 second, and wall time is 1.84 seconds. I will come back to this. So I should really, guys, have a put here using our standard X train and Y train data. Okay. What if we use that pipeline data, that data set object? Yeah. I mean, we have the same model. Okay. It's the same model. So how about if we go and run it instead of using our standard data, we go and use that pipeline structured data. So if I do again time, and then I'll write here using TensorFlow for efficient data pipeline. Okay, so we're going to just say for epoch in range 10. Okay, so that's the same thing. There is one difference here, yeah. We need to have another loop, okay? Because those basically data that we created, okay? Let me just call it data set. It was called, right? Data set. Okay. Let's just look at our data set. So that's our data set. Just look at this for I and J in data set and I. Okay, you understand? So we need to loop through it, yeah? And what is J? Okay, so shall we print J? So let's do it like this. Print I dot shape. Maybe that would be better. Yeah, so look at that. How did we make this, first of all? Our data set, we made it TensorFlow.data.dataset from tensor slices. We fed it our X train or our Y train, okay? And then we said dataset equals dataset, and we call the function .batch32. Now look what it's done for us. So the dataset has created these batches from our main data. We had 100 imaginary sort of images we created, yeah? So 32, 32, 32, and obviously the remainder is 4. So that's 66, yeah? Sorry, 96, and then 4 remaining, yeah, to make up 100 images, right? And if I was to say, um, print, well, I is going to be the label, isn't it? Let's just do print. Just say J is going to be the label, isn't it? These are the labels basically, okay? Again, J.shape, okay? So these are the labels associated with those, all right? So we can't just go and say, data set as like data set, right? You need to, it's an iterator, you need to iterate through it. Okay, so now that you know this, what do I need to do here? So I can do tuple unpacking technically and then loop through this iterator. So I'm going to say for X batch, you remember IJ, but now I'm just going to say X batch. For X batch and Y batch, label batch basically. I'm just using X and Y so that you're familiar with the previous example we did. Otherwise, I could have said, I or J or whatever name that you like to put. In dataset. Okay, do what? From this point, let's look, let's compare. Again, with TensorFlow dot gradient tape as tape spreads equals model CNN, yeah, and what we're going to feed into it. We're going to feed our X batch, okay? And what is our loss going to be? Loss is going to be, again, TensorFlow dot reduce mean TensorFlow dot keras dot losses dot binary cross entropy. Binary cross entropy, yes. And what are we going to feed into this? Obviously, it's going to be a Y batch, yeah, the Y batch, and it's going to be your threads again. So threads is just threads, okay? So do you see the difference between this and that? I'm just having to loop through that iterator dataset iterator, okay? Now the rest, do you think there is any difference, guys? I want you to think. Should there be anything different? Do you think? But no, not really. The rest of the task is the same thing. You calculate gradients, you use the optimizer with those gradients to adjust the variables, the weights or whatever. Okay. So now I'm going to, sorry, it should be here. Yeah. I'm going to say gradients equals tape dot gradient, and then loss is model dot model CNN dot trainable variables. Okay, and optimizer CNN column method of dot apply gradient dot apply gradients, zipping the gradients and model CNN dot trainable variable. Okay, so cool. Let me just see if everything's okay. All right, now let's just run the model again. So that's our model. Okay, cool. And make an instance of the model. This is our optimizer, except that we are not going to run this, but we have the time that it runs saved. Yeah, so let's see. And I got an error. Enter. Where is that error? Just give me a second. What did I do wrong? Oh my god. Okay. Sorry about that. Let's just clear this out. Cool. Okay, so how long is this going to take? Let's look. Okay, CPU time 1.87 seconds. System is 107 milliseconds. Total equals 1.97 seconds, and wall time is 2.6. Now, what does all this mean? So the CPU time is how much time basically is being used for all this stuff to be processed on the CPU. Yeah. Now the user is when the CPU is actually managing your task. Yeah. System is when the CPU is managing your stuff, well, utilizing its resources to do yours, okay? And total is them added together, yeah? So for example, imagine you go to a restaurant and you order a cheeseburger with chips, yeah? So the time it takes to actually go and get the burger, put it on the frying pan and fry it, yeah, and then put it on the plate, yeah, and give it to you. Think of that as a user time span. The system time is the time that is used to prepare the kitchen for preparing your burger, meaning the time it takes for you to go and pick the frying pan to come and put it on a grill and turn it on, for example, or like pick up the plates and bring it, I don't know, where you put the burger in. All right, that's the system time, and the total time is them two added together. And the wall time is basically the overall thing, like the whole thing, including other activities in the kitchen, that from the moment, like you order, for example, from the moment the waitress or waiter gets your order, yeah, then you add that time as that becomes wall time. It means from the moment you press enter to the moment that it's run and it's ready. Okay, so if you think about that, we can see that the first one seems more efficient. And this may raise the question that, hold on, you just said that what is all this TensorFlow pipeline efficiency if it just did that? Obviously, that doesn't seem efficient. But that one was better. Well, true in this example, but that's because we only had 100 data. Yeah, we only created what? Only 100 fake, 20 by 20 images. This will be significantly more efficient using the pipeline if you have 50,000 images of, I don't know, 40 by 40 or whatever. Yeah. So the larger your data set is, then this pipeline efficiency would show itself. Otherwise, yeah, just stick to using your data as it is. Yeah, like to explain that to you, for example, you can say, you can say that, okay, I'm going to learn how to use a calculator. Let's say you have never seen a calculator and someone tells you there's this calculator. Come, let me show you. Now, if you want to just multiply four numbers like 3 by 2, 5 by 3, and 3 by 3, and 4 by 1. Yeah, let's say these are your calculations. Well, obviously, just do them by hand. It's going to be much quicker than somebody coming and training you on a calculator for you to calculate these four numbers. But if there were 1,000 calculations you had to do, then it is worth spending some time on that calculator to then continue doing the calculations with the calculator. This is an analogy, and usually, analogies don't hold always, but I'm just trying to see if, like try to help you understand why you would use a timeline. Yeah. Then you would use this data set basically preparation by using TensorFlow.data set and then calling the method from tensor slices and then creating a batch. You only do this when you have really large data sets. Well, I hope you have enjoyed this video as well. As I said, these videos, I'm just making them so that you sort of understand what's happening, underneath, and get sort of used to this feel of what is TensorFlow is all about. All right, guys, take care.